In string theory, the math demands that every particle in the universe is simply a tiny one-dimensional string that vibrates at a specific frequency across 11 total dimensions. The mathematics are rigorous, but they rely on a massive assumption that a stage already exists for these strings to inhabit. Space and time are treated as a given in standard quantum physics. Researchers successfully break forces down into discrete units, excite an electromagnetic field, and you get a single independent photon, excite a gravitational field, and the math dictates a discrete graviton. We know how to divide the actors in the universe into their smallest, measurable pieces, but these theories stall because the same math fails to describe the empty stage they perform on. Space stubbornly resists being chopped into independent units. One major attempt to force the math to work is loop quantum gravity. This model suggests space is divided into a discrete spin network of tiny interconnected nodes and rings. But carving up space creates an immediate mathematical wall. If the physical volume of the universe is reduced to individual static chunks, the flow of time loses its mathematical anchor and disappears from the equation. Furthermore, these geometric loops are not physical objects you can isolate in a lab. They are abstract mathematical boundaries representing isolated units of area and volume. Treating the void as a physical object causes the model to collapse. The math suggests space-time exists as a secondary illusion rather than a fundamental building block. In 1997, physicist Juan Maldacena proposed a mathematical framework called the ADS-CFT correspondence. He demonstrated that a universe containing gravity in 3 dimensions can be perfectly mapped by a flat, 2-dimensional boundary containing no gravity at all. In 2006, Ryu and Takeyanagi found the mathematical link. They proved quantum entanglement on the flat boundary calculates the physical volume inside. Entanglement serves as the blueprint for distance. Links between data points create the geometry we perceive as space. The empty box of our 3-dimensional universe doesn't hold quantum information. The quantum information generates the box as a massive holographic projection. In 2000, physicist Mark van Ramsdonk published a proof applying this logic to large macroscopic sections of space. If you take 2 entangled regions and sever their quantum connections, the physical distance between them actively stretches and deforms. When entanglement drops to 0, space rips apart. You are left with 2 isolated universes completely cut off from one another. Without entanglement, there is no geometry. It is the literal thread holding reality together. By 2013, Maldacena and Leonard Susskind scaled this math down to the smallest possible metric. They proposed the ER equals EPR hypothesis. When 2 individual particles become entangled, they tear a microscopic wormhole through the projected geometry, connecting them directly. In 2022, researchers tested this using Google's Sycamore quantum computer. They built an entangled system of quantum bits, mathematically designed to simulate this exact structure. When they injected information into one side of the system, it scrambled and instantly emerged on the other side, matching the behavior of an object passing through a holographic wormhole. Entangled particles bypass distance by using physical shortcuts wired into the hidden architecture of the universe. Applying this framework to the real universe creates a paradox. We know space is expanding. If space is built from entanglement, does that imply the universe is generating new quantum connections? Quantum mechanics forbids this. The total quantum information in the universe, the sum of all possible probabilities, is a strict mathematical constant. It must always equal exactly 100%. Physicists point to a solution called quantum complexity. The system isn't gaining new information. Instead, the existing connections between nodes are restructuring and complicating themselves at an enormous rate. As the internal web grows denser, that increasing complexity manifests physically. It forces the outer boundaries of the geometry outward to accommodate the data. The expansion of the universe is the natural byproduct of fixed quantum code becoming more complex. Space grows from the inside out as the internal network matures. Space-time emerges as a secondary consequence of quantum entanglement. The geometry we inhabit is the result of deep-seated information complexity. But this leaves one massive piece missing from the equation: time. If three-dimensional distance is merely an illusion projected by a network of flat quantum data, what dictates the flow of time within that projection? Proving that space is emergent doesn't complete the model. It strips away the first layer, forcing us to confront the deepest, most resilient mystery in modern physics, the problem of time.